Hey guys, we are still doing chapter 1, lesson 7. Can you believe this? So we're going to focus in on, where are we? I'm writing 3s and it's supposed to be A. Lesson 1-7, and today we're going to talk about function machines and function notation. Oh, I'm writing function and function. Let's try that again. Function machines and function notations. Okay. Actually, probably will show you a video tomorrow in class. Somebody else did that I thought was pretty cool. So, what is a function? So, we talked about parts of a function. We talked about the definition of a function. But here's another way of thinking about it. A function can be thought of as a machine that assigns one output to every input. Okay? So I'm going to draw a big function so that you can understand what it looks like. So f is actually the name of the function. It's function f. Okay? And x, or whatever you see inside the parentheses, so inside the parentheses is the input. Of the function. So it's basically telling you this function is defined in terms of x, okay? And these values are substituted into the function. Okay? So then when you look at these two pieces together, the f of x, that's actually the answer. So f of x is the output of the function f. I forgot what color I was doing, red. When the input is x. Okay. Now, what some people refer to this is function notation. using f of x okay, and then the 3x plus 4 is the rule. So it's basically how you determine what the output is, you apply this rule. So it's the rule used by the function machine. Oh, used by the function machine. Okay, so what I'm going to do is give you an illustration and just kind of draw out a kind of a funky picture. And we're going to take f at 2 and f at -1 using a function machine. So we're going to use f at 2 and f at -1 using in the function machines. Let's say that. Okay, so we're going to draw this kind of funky looking shape. Boop, 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 boop. So we're going to put into the function machine, we're going to put the input value. And the input value is what's inside the parentheses. So we're going to plug in a 2. Okay. Now the rule says we're going to have 3x plus 4. So we're going to take and substitute in 2 for the x, and then we're going to solve. So we get 3 times 2 is 6, 6 plus 4 is 10. So that's what comes out is the output, and the output is 10. So we could conclude that when the function inputs 2, out comes 10. Alright, so let's do another one. Kind of lower this down. Kind of a funky, skinny one I did, huh? Yeah. So this time I'm going to input -1. The rule stays the same. 3x plus 4. The only thing that changes is what I put in for the x. In this case, it's -1. You're hearing rustling, my cat's walking on the bed. So 3 times -1 is -3. -3 plus 4 is going to give me a positive 1. So we can conclude that the value of the function at -1 is equal to positive 1. Okay? Alright, so that, let's see. So all we're using is substitution. So we substitute input into the rule, then solve for the output. So I'm going to color code by boxing up. So we're going to substitute the input into the rule, then solve for the output. Okay? Alright, so next page we're going to do a whole slew of examples. Yay for examples! You might not be saying that, but I am. So we're going to do let f of x equal x squared plus 3 and g of x equal x plus 1. I think that's right. Yep. Okay, so they're going to ask us to find the following values. So we're going to start with f at 3. Okay, so what that tells us is that we're going to use the input of 3 in for the x. So it's 3 and then squared plus 3. Excuse me. Ooh, that was a weird tickle. So we get f at 3 is equal to 9 plus 3, which equals 12. So that is our conclusion on that one. So that is our output is 12 when our input is 3. Okay, let's try another one. What if they want us to figure out what the value of the function g at 3 is? So remember, going to have the input is going to be the 3 again. And this time we're going to have the rule changes to x plus 1. So in our case, 3 plus 1. So then we get the value of the function g at 3 is equal to 4. That's the output is the 4. Okay. Next one, let's do the value of the function f at -2. So again, the input is the -2. So we're going to get -2 squared plus 3. So the value of the function f at -2, -2 squared, 2 negatives make a positive, so that's going to be a positive 4. And I get the value of the function at -2 is equal to 7. So 7 is your output. Okay. What if I have the value of the function g at 0? So remember, 0 is our input. So every time I see x, I write 0. So it's 0 plus 1. And I get the value of the function g at 0 is equal to 1. So 1 is our output. Input, output. In fact, you could take what's inside the parentheses and the answer and write them as an ordered pair, right? That would work too. All right, got some more examples. Ooh, now we're going to get complicated. What if I want to figure out the value of the function f at 2 and add it to the value of the function of g at 1? Okay, so now I have to use both of those equations, but what I'm going to do is substitute in 2 to the f, so into the function f, so that's going to give me 2 squared plus 3, and then we're going to add to that what we get when we put the input of 1 in for x in function g. And we just follow order of operations. So I get 4 plus 3 plus 1 plus 1. And that's going to give me 7 plus 1 plus, oops, that's not supposed to be a plus plus or a minus. 1 plus 1. And that's going to give me 8 plus 1, which gives me 9. So the value of those two functions together is equal to 9. So the value of the function f at 2 plus the value of the function g at 1 is equal to 9. So 9 is your final output for the combination of those two functions. Okay, let's try another one. Some of these get really bizarre. So we're going to have the value of the function g at negative 1 plus the value of the function f at 1. So when we see x in the function g, we're going to substitute in negative 1. But in function f, where we see negative 1, we're going to substitute it in function f's rule, which would be 1 squared plus 3. So I get 0 plus 1 plus 3, which ends up giving me 4. So I can say that the value, oops, I got so excited there with f's in the front. The value of the function g at negative 1 plus the value of the function f at positive 1 yields 4. 4 is your output. Now these you could not do the ordered pair when you're doing a little math in between. Alright, still got a couple more. Oops, sorry, I already did 6. Let's try that again. 7. So let's see. Ooh, this is where it gets super interesting. The value of the function f at the value of the function g. Whoosh. Okay, so here's what we do. We're going to work from the inside out. I'm going to figure out what the output is for function g when I put in 2, and then I'm going to take that answer and put it into function f. So we're going to start with the inside. I'm going to start with this part here, and we're going to see g at 2, that's your input is 2, is equal to 2 plus 1. So when I solve that, I get the value of the function g at 2 is equal to 3. So now what this problem looks like is the value of f at that output value, 3. So then I substitute 3 in for the x in function f. So I get value of, let's just do this. So we've got, this is going to be equal to 3, because now it becomes an input value, right? X squared plus 3. So we're going to get 9 plus 3, and we get the value of f of x, or f at 3 is equal to 12. So our full conclusion would be the value of function f at the value of function g at 2 is equal to 12. So again, that's your final output on this one. Okay, let's do another one. And we've got g at the value of the function f at the value of 0. Okay, so again, we're going to start with what's inside, get him down to one number, and then we can solve the problem. So 0 is going to be my input value. Function f says you take x squared and then you add 3 to it. So this is our function at 0. So we get the function of f at 0 is equal to 3. So then I'm going to take that output value, and now it becomes the input value for function g. And then we're going to see every time we see x, we're going to put in 3. Alright, so this equals 4. I'm going to put it right here. So I can go back to the very beginning and say the value of function g at the value of function f at 0 is equal to 4. So 4 would be the output of that combination of the functions. Let's see. Alright, I've got 2 more, and then we'll call it quits. So we've got the value of function f at y. So what that says is y is the input. So where I see x, I'm going to put y. Okay, now that's all we can do because I can't do y squared plus 3. So that is going to be my output. It's going to be y squared plus 3. All right, last one. I promise. What if we have the value of function g at w? Well, remember, w is going to be your input. And then every time I see x, I'm going to substitute that value of w. Now again, I can't add w plus 1, so I'm done. So the value of the function g at w is equal to w plus 1. All right, that's what I got for you guys. Have a good one. Bye-bye now.